Hey guys, Dr. Brown here, and tonight we're working with the Calculus 1 group, and we're looking at the derivative of the natural log of x squared plus 4x plus 5 plus tangent inverse or arctan of x plus 2. Hey, so let's get after it here. All right, you know from the derivatives of natural log, well, in Calculus 1, you may not know this, in terms of how you get to a natural log is the derivative of a function over the function, in this case du over u, derivative of a function over the function. So when you take the derivative of that, in this case with respect to u, the integral sign goes away and you're just left with the derivative of the function over the function. So that's the case we have here. If we take the derivative, and you know by the sum difference rule, in this case the sum, we can take the derivative of this plus the derivative of that, and that gives us the derivative of the entire function here. All right, so we end up with the derivative over the function. The function is x squared plus 4x plus 5. The derivative of that, bring the 2 down, x to the 2 minus 1, just to the first. So derivative of x squared is 2x plus derivative of 4x, that's x to the first, bring the 1 down, 1 times 4 is 4. X to the 1 minus 1 is x to the 0. Any number to the 0 is 1. If you say 0, I'm coming to your house. All right, so that's the derivative of the function over the function. Okay, that's the derivative of natural log of that item right there. Now, what are we going to do with this guy? Tangent, we're trying to take the derivative of tangent inverse x plus 2. Now, we know the inverse in your trig, if you're looking at this, we know that theta equals tangent inverse x plus 2. We can take sine inverse, cosine inverse, and when we do that, we take some values and we translate that into an angle. Well, in our case, we're trying to take the derivative of that. So I'm trying to take the derivative of both sides of this thing, or the derivative of theta, which would give me what? D theta. So I need to do something to come up with a d theta. All right. This implies, go back to this, theta. This implies that tangent of theta equals x plus 2 over 1. That's what that implies. Now I can get a d theta if I just take the derivative of this. So I'm going to take the derivative of both sides. Okay, the derivative of tangent is secant squared theta d theta, chain rule, and that equals derivative of x is 1, derivative of a constant is 0. So to solve for d theta, that equals 1 over secant squared theta, and 1 over secant squared is what? Cosine squared. So d theta equals cosine squared theta. Okay, let's put our triangle up here. If this is theta, and I would encourage you just write the angle like this. Everybody keep the angle pointing in the same direction. Let's see, tangent of theta is x plus 2 over 1. It's opposite over adjacent. That's tangent. So that means that this side is x plus 2 squared plus 1 squared. And 1 squared obviously is 1. Okay, let's go ahead and FOIL that out and see what we get. X plus 2 times x plus 2, and all that's plus 1. So I have x squared plus 2x plus 2x, so that's 4x. And then 2 positive 2 times positive 2 is plus 4, plus that 1 gives me x squared plus 4x plus 5. Okay, so this would be the square root of x squared plus 4x plus 5. Okay? So if I have cosine squared, cosine of theta is the adjacent over hypotenuse. So I have 1, so cosine, let's see, d theta equals cosine squared theta. And we said cosine was 1 over the square root of x squared plus 4x plus 5. That's cosine, but it's squared. So the radical is going to drop away. All right, so that's d theta. So that's the derivative of tangent inverse x plus 2 is 1 over x squared plus 4x plus 5. Now you'll notice I have a common denominator here. So I have x squared plus 4x plus 5, and that gives me 2x plus 4 plus 1, which is 2x plus 5. So that becomes the derivative of the natural log of x squared plus 4x plus 5 plus tangent inverse of x plus 2. We ended up with 2x plus 5 over x squared plus 4x plus 5. The only challenge here is understanding the rules of the derivative of natural logs and how to take the derivative of an arctangent or arcsine, arccosine. This is something you really need to get down pat in your mind. As a matter of fact, it may be that you need to just memorize some of these derivatives. I'm 67, I've long since forgotten them. Okay, so I end up just trying to remember how to work it out. Okay, why are we doing this? Together we're trying to build a better tomorrow and do that through math. Keep studying. We'll talk to you next time. Thanks.